Number 5 has an identity it starts off with. It says, use this identity here. And that should be somewhat familiar to you. It's a product of difference or a product of sum, depending how you want to look at it. And they want me to use this to show this over here. So we'll do that, and then we'll start going through like A, B, and C. But we do one thing at a time. So what I want to do is go to the whiteboard and write down what they've given me. And again, I'm not trying to memorize what I've read. I'm trying to read it. Number 5. And I've been told, there's no need to verify this, by the way, but it's true, that the sine of alpha times the sine of beta is equal to cosine beta minus alpha minus cosine of beta plus alpha. All right? By the way, you know what? I am going to go and verify that for you. And the reason for that is I just want to point out that a lot of times you're given things and it may not be true. And you use it, suddenly you're in a really a bind thinking it's true. So I'm going to verify by looking at this side over here and just write it down, by the way. So cosine beta minus alpha, that's going to be cosine beta cosine alpha plus sine beta sine alpha. I'm also going to write down cosine beta plus alpha. Sorry about that. That's cosine beta cosine alpha, and that's going to be minus sine beta sine alpha. And I can subtract these guys. What do you get? Cosine beta minus alpha minus cosine beta plus alpha equals, these would disappear, and you're left off with sine beta sine alpha plus sine beta sine alpha, which would give me 2 sine beta sine alpha. We're getting exactly what they said it is. So we're going to use that. All right, we're actually going to use that. All right, and how are we going to use it? I got to find out what they want me to do with it. And I'll write it down for you. They want me to use this over here. Let me write this down again. We're showing the same thing. 2 sine alpha times sine beta is equal to cosine beta minus alpha minus cosine beta plus alpha. All right? So what do they want me to verify? They want to verify this over here, that 2 sine, this is a theta now, all right? And then they got this, crazy looking thing over here, sine theta plus sine 3 theta. That jumped up by 2, by the way. And then it jumps up another 2, sine of 5 theta. I get the idea, 7 theta, 9 theta. It goes yada, 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 all the way up to the sine of, I'm going to write this down, 2n minus 1. That's an odd number, by the way. And then you get theta over here. And this is going to be, they say this is equal to 1 minus the cosine of 2n theta. So someone says, how would you do that? They gave me a hint. They said use this to do it. And so I'm going to do that. And if I do that, I'm going to take the left side. I'm going to start to expand it out. And what would you get? You would get 2 sine theta sine theta. All right? And then the next one's going to be plus 2 sine theta sine 3 theta. What's the next one going to be? Plus 2 sine theta times sine of 5 theta. And by the way, this keeps going on. I'm kind of running out of room, by the way. But the last term is going to be 2 sine theta times sine, well, it's going to be complicated, 2n minus 1 theta. And they want me to show that this is equal to 1 minus cosine 2n theta. Well, I got some troubles. The trouble is I got to write these down, all right? So looking at this thing over here, I want to point out just the first term. This is going to be alpha, and that's going to be beta. So I think I can write that down. I'm looking at this over here, by the way. That's all I'm looking at. I see the 2, sine alpha, sine beta. Now, alpha and beta are the same thing. They're both beta, all right? So what'd you get over here? We're going to expand it. We're going to get cosine. Well, let's see. What's beta minus alpha? That would just be 0, right? And then what do you get? Minus the cosine. Well, beta plus alpha is going to be 2 theta. All right? I got that one done. I'm going to cross it off. Let's do the next one. Plus. This is now alpha. This is now beta. All right, let's write that down. So what's it going to be equal? It's going to be equal to the cosine of beta minus alpha. That's 3 minus 1, which is 2. Minus cosine beta plus alpha, which would be 4 theta. All right, let's go to the next term. Plus. This is alpha. That's beta. Now I'm starting to see a pattern here, but I'm still going to write it down for you. It's going to be cosine. Well, that's going to be 5 minus 1, which is 4 theta. This is what's known as a telescoping series, by the way. Then minus the cosine of 5 minus 1, which is 4, which is 5 plus 1, which is going to be 6 theta. And this marches along, plus, dot, 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 plus. Let's do the last one. What's the last one going to look like? All right, let's put this down. And the last one, what do you get over here? This is alpha, and this is going to be beta. All right, a little more complicated, isn't it? Cosine, and again, I'm looking back over here, beta minus alpha. So it's 2n minus 1 theta, that's the beta, minus the theta. Well, this is 2n theta minus theta minus theta. All right, what do you get there? Let's see what you get there. Got to make sure I got that right. Did I do that right? Let me take a look. Beta minus alpha. Yeah, it's not so bad. So what do you get over there? You get, I'm going to write it down this way. 2n minus 1 theta. I don't think this adds much to it. And then minus theta. And then what do you get? Minus cosine. Well, now I got another problem over here. I have to add them together. Let me write that down for you. So it's 2n minus 1 theta plus theta. And, it's not that bad to do. What do you get? You get 2n theta minus theta plus theta, and they just cancel off. So what do you get? 2n theta. All right. This was known as telescoping. I want to point out what I mean by that this thing's going to collapse like a telescope. This would cancel that. This would cancel that. Now, I didn't write it down, but there's going to be another term over here, and this would cancel that. And so would everything else in the middle. But there'd also be something to the left of this one that would also cancel off. So what are we left off with? We're left off with cosine of 0 minus cosine of 2n theta. All right? So what did we just show? Let me write that down, by the way. We have showed that expansion actually equals what they said it does, which is 1 minus cosine 2n theta. And we showed it. It's done. Q, E, D. Let's go back to the original question. I want to point out what we just did over here. We just verified that this, if I use it on this thing in the expansion, I would get this thing over here. Now what we're going to do is we're going to go to A, and then we're going to go to B, and then we'll go to C, and see how that works out. All right? Thank you. By the way, something about this one that we just did is going to be useful. I can guarantee you that.